This is lesson 4.5. This is the multiplication rule with complements and conditional probability. Now conditional, guys. If something's conditional, then there's a condition to it, right? There's like you have you can do this, but you can, but that, but you have to do that first or something like that. Your parents give you conditions all the time, right? If you want to go out for ice cream, then you have to clean your room first. I don't know. So that's kind of a dumb idea, but anyway, that's what conditional is. So we have information indicating some event has already occurred, and we have to find the probability of a new event. Now, the complement is the probability of for the probability of, quote, at least one, close quote. Now, I'm going to talk about what that means here in just a second, but what we're going to be solving today, we have to think of kind of in a backwards way, okay? We're going to need to find the probability of something occurring, but we're going to first find the probability of it not occurring, because it's easier to find the not occurring than the occurring, okay? Or it'll be faster, or whatever the reason might be that we might use this method, okay? So here's what we have. If A represents the probability of at least one of some event, then its complement is getting none of that, okay? Getting none of the A. And the probability of the complement would be the probability of A not occurring. Once we know the probability of A not occurring, we can subtract 1 from that probability, and that will tell us the probability of A. Okay? So it's kind of thinking of it backwards. I'm going to do my best to help us understand this as we move forward. This shouldn't take us too long to go through, though, so hopefully it makes some sense when we talk about it. Now, we're going to use this here in just a minute. That's why it's still up here. So let's say that some DVDs are sold in packs of 10, or sorry, packs of 50, okay? Now the probability is given for a defective DVD as 0.005. So the probability of getting a defective DVD is 0.005. The probability of getting a good DVD, that probability then is 0.995. We want to find the probability of at least one defective DVD. Okay? The probability of at least one defective DVD out of all 50 DVDs. Now here's the reality, guys. To do this, we got to think backward. We're going to find the probability of it being good. So the probability of good is kind of intense. For each DVD, we have a 0.995 chance of it being good. So that would be 0.995 times 0.995 times 0.995, 50, yeah, it's sold in 50 times. We don't want to do that, so to make life a little bit easier, we can just, since we're multiplying the same number 50 times, we can just do 0.995 raised to the 50th power, and that answer is 0.778. Okay? So that is the probability of it being good, of all 50 of them. Okay? The probability of it being good. Now this is a basic example. You probably would just find the probability of it being defective and you'd be just fine, but we're getting used to this idea of using the complement, okay? Now, what we're going to do now is, since that's the probability of it being good and we want to know the probability of it being bad, all we have to do is take 1 and subtract 0.778 from it, and the answer we get is 0.222. There is a 0.222 chance of you getting a defective DVD. Okay? Now, conditional probability. This is going to go back to something we mentioned earlier in another video. But conditional, that's when you'll see something like this. Probability of B after A has occurred, right? Now the reason why this is conditional is because you have to find the probability of B event knowing that A event has already occurred, okay? So it's conditional based off of what happened with A. So we're going to go back to this pre-employment drug screening, which I still have the data up there for. And let's say that we want to, let me give you a formula for how to solve the probability of B knowing that A has occurred. The way we're going to solve it is we're going to find the probability of A and B and divide it by just the probability of A. That's the rule. It's that simple. If you find the probability of A and B and then you divide it by the probability of A, that'll give you the probability of B knowing that A has occurred. Okay, so here we go. We want to find the probability that the subject had a positive result given that that subject uses drugs. So we want the probability of positive knowing that that person does use. Okay? So let's go ahead and figure this out first. The probability of both of these would be this. Positive and uses would be 44 out of 1,000, right? So that's the probability of A and B, that they have to be positive and use. Positive and use is 44 out of 1,000. Adding all these together is 1,000, right? Then we want the probability of just A, so the probability of getting a positive. Well, the positive results are for users, right? There are 50 of the users who have positive results. So that would be 50 out of 1,000. Guys, basically what's going to happen here is you take the bottom, you flip it to the top, the thousands will cancel out, and you'll end up with 44 over 50. But either way, if you plug this into your calculator, just make sure you put that into parentheses and that in parentheses. You do this parenthesis divided by that parenthesis, and you'll end up with the right answer. And the answer you'll get is 0.88. Okay? So, sorry. This bottom part, I know what I was thinking. This bottom part is the probability of A, which is the users. There are 50 people that use out of 1,000. So 50 out of 1,000. Okay, that's where that bottom number comes from. The top number is both of them, positive and uses. That's 44 that are positive and uses out of 1,000. Okay, so we'll do another one. We want to find the probability of someone uses and they get a positive result. So probability of uses and gets a positive result. Now guys, we already know the positive results happened, right? So if the positive result has already happened, we're going to use the formula. We first want to identify the probability of both of these occurring. So we're looking for those that use and have positive. Well, the users and have positive are 44. Uses and positive are 44 out of 1,000. We're going to have the same type of situation occur here as in the last one, but there is going to be a difference this time. The probability on the bottom is the probability of just this, the probability of this event here, A. Okay? The probability of having a positive, well, these are all the positives, 90 and 44. 90 plus 44 is 134. So there is 134 out of 1,000 that have a positive result. Guys, again, you're going to flip this one up to the top and multiply. The thousands will cancel out. You're really going to end up with 44 over 134. But you can just use it in your calculator. Just make sure you put the top in parentheses and the bottom in parentheses, and you divide them. And when you finish solving this, you will get 0.328. The last result, when we did positive and uses, that one was 0.88. These two answers are not the same, okay? And it's important to recognize that. That it is not the same thing. Let me put that on here. This one was the probability of positive after knowing that they are a user was 0.88. It's important to know that this is not the same as that, okay? And there's a lot of times you can make mistakes thinking that the inverses of these are the same when they have nothing in common. This idea of thinking that those should give you the same answer when they don't, that is called the confusion of the inverse, okay? So it's important to know those two things do not add each other, okay? All right, that's it. Or do not equal each other.